Well, it seems as if I did the whole lecture, but I forgot to hit record. So I'm going to start over and see what we can do to talk through this lesson. So I think the first thing is we're going to be taking inequalities called constraints, okay, because they hold in the values that could make this true. And we're going to be saying, okay, every shaded region has infinitely many points within it. But my question is, which one is best? You're like, I don't know, they're all valid. And the answer is, of course, that's true. However, if we have an objective function, so like a purpose, okay, we're like, hey, my purpose is that I want to, get the most income, or I want to have the least cost. Okay, so you're going to have an objective function. It may be a word problem or it may just be an equation. A lot of times it talks about P equals and it talks about both X and Y in an expression, or it could be F based on X and Y, and then they'll give an equation on the right side. And what we do is we have to say, of all the shaded values, which one will help us maximize or minimize our function or our objective function. And so I think the big thing is there's a lot of points and we don't want to try them all. So the question is, how do we figure out which one's best? Well, the max and the min of any objective function of a shaded region will always occur at a vertex. And so how we are going to do this is we're going to graph the inequalities. Okay, and you guys did this yesterday. And so my handwriting is horrifying. It's hard to write with this script, but so let's see what we can do together. If you graph X plus Y equals 70, okay, she wants to make fewer than 70 plates. Find the intercepts, show me this table right here, plot them, okay, and then pick a point. Say, hey, should I shade above or below that? The point 0, 0 for X and Y does make this true, so we're going to shade below that first line. And I have that graphed, it looks like in black. Okay, so that one's in black. It's good to make like a little key. The second one I have is going to be her cost. Okay, so and I've graphed that in red. It looks like if you plug in X is 0 and you make 0 of the red plates, then you're going to be able to make 55 of the golden plates. So 0, 55 would be the first point. And then if you plug in 0 for the golden plates, you could make 82 and a half of the red plates, or the gold plates, or red, sorry. Now, the thing is, obviously, you're not going to make 82.5, but if you want to show the feasible region, you need to have it exactly the right size so that when you look at the shaded region, you can make sure that you can have all the values that make it true shaded. And so I think the big thing would be then, X is greater than or equal to 0 and Y is greater than or equal to 0. You can't have negative plates. And so the darkenly shaded region, I will shade in green. Okay, so that's this part right here. And the thing is it has 4 sides. You have to find out the 4 vertices of that 4-sided darkenly shaded region and put them on a table. So 0, 0 is in the bottom left corner, so that's here. And the objective function is her profit formula. Okay, it says, hey, how many plates should she make? Well, they're all valid options. There's a lot of values that she could do. But if her objective is to make a profit, her profit is $5 for every red plate and $8 for every golden plate. And so we're going to plug in the vertices of the darkenly shaded region into the objective function and see how much money she would make based on each thing. And so 0.55 is going to be up here, and that will give her $440. And then over here is 70, 0, and that gives her $350. And so to find the slanted value here, if you can tell precisely and exactly from your graph what it is, then you should do that. But if you cannot, then you've got to use substitution or elimination to help you find the intersection of those values. And so I went over here and I said, okay, let's write down the equations of each of those slanted lines. Here's one right here and here's the other one right here. And I put them above each other. Here's X plus Y equals 70. And then the second one, I moved the 50 to the other side by subtracting it, and I got 2x plus 3y is equal to 165. Yes, that's 3y. It looks like who knows what, but 3y. And I did elimination. I multiplied the top equation by -2, and I got y is 25. I plugged that into the top equation to find what x is. So the ordered pair where those 2 slanted lines intersect using substitution would be the value of 45.25. So if you try 45.25, this is that point that's intersecting there at the top. You get 425. So which will give us the most profit? Well, that would be if she makes 0 red and 55 golden. So what I'll look for when you're doing this is, did you label your x-axis? Did you label your y-axis? Did you define your variables to say x is the number of red plates and y is the number of golden plates? Did you show me the intercepts? Did you graph them? Did you precisely find the points of intersection? And then did you make a table to show what are the vertices of the darkly shaded region and what would be their profit based upon each one? And so that's kind of what we're looking to do on this first question. Well, some of them aren't word problems, and that's fine, but you'll look at the darkly shaded region and say, okay, of those darkly shaded points, which one will help us to maximize or minimize the profit? I'm going to pause this a second. So I think the big thing is, we want to make sure, like, although there's a lot of values that are shaded, which one will yield the biggest profit, result, okay, output using the objective function. So that would be the max. And we want to find the minimum. And so both the max, the high and the low of a shaded region, as long as it's bounded, will always occur at the vertices. So if you try the vertices into the objective function, you're going to find the max and min. So the maximum output is 11, and it occurs at the point 10.3. The minimum of the objective function is -18, and that occurs at 3.8. And so we're looking to say, how can we find the max and the min, although there's a lot of values shaded? And I think the big thing I would say for you guys would be, as long as it's bounded, the max and the min will be at vertices. If it's unbounded, it'll have a max or a min, but not both. Because kind of like the Wild West, people thought they could keep going forever and ever and ever. And so if it's unbounded, there's going to be a max or a min. But as you travel within that region, your outputs for the objective function those outputs will get bigger and bigger and bigger, or smaller and smaller and smaller. You have to just kind of test the waters to see what's happening. Just like you could pan for gold as you move west to see, hey, how does this turn out? And so let's look at the next part of these nodes. Oh, whoopsie. Anyway, let me see if I can get this to move for us. Oh dear. I'm having a little struggle. I'm going to pause this a second. Okay, I'm going to see if I can make this work. I'm going to see if I can make this work. So as you graph these, the top one says x is between -1 and 6. So it's an easy way to say, hey, can I graph the lines x is equal to 6, and x is going to be, or it would be less than or equal to 6, and then x is greater than or equal to -2. And so you'd graph the values between those two vertical lines, kind of like a touchdown. And then the y, these are horizontal lines that you're graphing the lines y is less than 5, as well as y is greater than 1. And then the slanted line start at 3, go up 1 and over 1. The vertices, you can catch those from the dark and the shaded region pretty quickly. You don't have to really do substitution, elimination, or graph, or you can look at the graph and be able to tell. These 4 ordered pairs are going to be the vertices of the dark and the shaded region. And if you plug them into your objective function, the bottom equation, you can find the max and you can find the min. The max will be 12. It occurs at -2.1. The min is -28. She occurs at 6.1. So graph the region, find the values. Again, if you see x is between that's just 2 vertical lines and shaded between. Y is between 1 and 5. That's 2 horizontal lines and shaded between those. So I'm going to try to shift this over. Okay, it's working. Now, the next one, if you graph this, y is less than or equal to 8. That's a horizontal line. If you graph these other 2 lines, you will see that it's going to be shaded in this region, but it's unbounded. So that means it has a max or a min, but not both. And how you figure out which one it has is you try the vertices that you see, okay, -4, 8, and 2, 8, and then you do a test point in that unbounded territory and say, okay, see what happens. Well, if you try those 2 vertices, you get -84 as a result, you get -30. And then if you try one of the values within this unbounded region, you notice if you try a couple of them, the values are getting bigger and bigger and bigger. Just like as you move west, there was more and more gold as they panned for gold, in the waters out there. And so that means for this region, there is a minimum, but there is no maximum, because the further you go out there in the uncharted territories, the results of that objective function is going to get bigger and bigger and bigger. So you say there's no max, but the minimum is -80%. negative 4.8. So I think the big thing is, as you're doing these graphs, you're going to find the vertices, and if it's unbounded, there will either be a match or min, but not both, and you have to test the waters to see what's going on in the uncharted territories. Thank you. Have